Good evening. My name is Prithvisha Nath. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. I am the TA for this course, Vibration of Continuous System. So we will solve some questions for this week. So let's start. The governing differential equation of motion for a string is given by this equation. Where Fxt is the distributed transverse force and S is the tension in the stream. Where Fxt is the distributed transverse force and S is the tension in the string. Now we can write this equation in this form also. Now, if the string is having free vibration, that is Fxt is 0, and suppose S is also uniform in the string. So this equation can be written as follows. For free vibration, Fxt equals 0, and let's assume that S is also uniform, and S is uniform, and mx is given as rho. So we can write this equation as, this equation number 1 as this equation, where C is expressed as square root of S by rho. Now we will need this equation to solve our problems. So moving on to the first question, determine the velocity of wave propagation in a cable of mass rho equals 5 kg per meter when stretched by a tension T equals 4000 Newton. So in this question, tension is mentioned as T in place of S. So what equation can we use? We know that C equals square root of S by rho, and in the question tension and rho both are given. So the tension in the cable is tension in the cable equals, so here as I said tension is mentioned as T, so I'm writing it down, that is equals 4000 Newton, and the mass per unit length that is rho is given as 5 kg per meter. So C equals square root of T by rho, where C equals the velocity of wave propagation. So what should we do? We should just simply substitute the values in place of T and rho. So 4000 divided by 5, this comes to be around 28.28 meter per second. So this is the answer for this question. Now moving on to the second question. A steel wire of 2 mm diameter is fixed between 2 points located 2 meters apart. The tensile force in the wire is 250 Newton. So there are two parts to the question. Determine the fundamental frequency of vibration and the velocity of propagation in the wave. So what do we know here? What are the informations given? We know the diameter of the wire and the length of the string, length of the wire, and we also know the tensile force, that is tension in the wire is 250 Newton. So what is asked? We have to find the fundamental frequency of vibration and the velocity of wave propagation. So first we will write down the given informations. Diameter of the wire is 2 millimeters. So we can convert this to meters since all the information is in the SI unit. So that is equals 2 into 10 to the power of 3 meters. So here we can assume the mass density of the wire to be the density of the wire to be 7830 kg per meter cube. Now how can we find rho? That is mass per unit length. If we multiply the mass density with area, we get the mass per unit length. Density has a unit kg per meter cube. If we multiply with area, so we get the mass per unit length. So rho equals density into area. That is, now what is the area? How can we calculate the area? So the area is pi d square by 4, that is pi into, what is the diameter? Diameter is given as 2 into 10 to the power minus 3 whole square divided by 4 meter square. Now we can substitute all this information for calculating rho. So rho is equals Density is 7830 into pi into 2 into 10 to the, no, this is 10 to the power minus 3 whole square by 4. So this comes to be around 24.5987 into 10 to the power 3 kg per meter. Now we have to find the velocity of wave propagation. In the question we know the tension is given. What tension is 250 newtons. So we know tension in the wire is 250 Newton. So the velocity of wave propagation, same as before, is given by C equals to root over tension. Here also I am denoting it as T. So T by rho so I am substituting the values. This is equals to 100.81 meter per second. So this is the answer to the second part of the question. That is the velocity of wave propagation on the wire. Now we also need to find the fundamental frequency of vibration. Now we know the frequency of vibration is given by omega n equals nc pi by L. Now since we are asked to find the fundamental frequency of vibration, n equals 1. So for fundamental frequency of vibration, n equals 1. So omega is C pi by L. Now we know the length of the wire to be is given as 2 meters. And we have already calculated C. So we can just substitute it in the formula. C is 100.81 into pi by L. L is 2. So this is equals 158.35 radians per second. So this is the answer to the first part of the question. Moving on to the third question. A tightly stretched string with fixed endpoints at x equals 0 and x equals pi is initially at rest in its equilibrium position. If it is set vibrating by giving to each of its point an initial velocity given by this expression, then find the displacement y at any point of the string at any time t. So here we are given a velocity and it is a fixed, the string is fixed at two ends, that is at x equals 0 and x equals pi, and it is at rest initially at its equilibrium position. So we are asked to find the displacement y at any point in the string. So how can we find this question? We know from the uh, from this equation we can see how the equation for a vibrating string. We know this is the equation for a vibrating string. So we have the equation for a vibrating string. The equation for a vibrating string is given as now we can express this equation like where the general solution is for this equation plus C2 sine PCT C3 cos Px plus C4 sine Px. So what are the boundary conditions that are given? For this question, what are the boundary conditions? From the question we can see that the string is fixed at the end position. So at x equals 0, y equals 0. So what can we get from this? Putting 0 in place of y and x, we see that 0 equals, now putting x equals 0, C1 cos PCT C2 sine PCT. Now only C3 remains. This fourth term, like the sine terms become 0. So only C3 remains. From this we can say that C3 equals 0. Now putting C3 equals 0 in equation 1. Suppose this is equation 1. What we get? Y equals C1 cos PCT plus C2 sine PCT C4 sine Px. Again we know that at x equals pi, y equals 0. Pi is the other end of the string. So at x equals pi, y equals 0. So we will put this in this equation number 2. Suppose this is 2. We put this value in equation number 2. So what do we get? 0 equals C1 cos PCT C2 sin PCT C4 sin P pi. Now we can see that C4 sin P pi equals 0. So from this, what can we say? Sin P pi equals 0. So from this, what can we say? We can say that sin P pi is sine in multiple of pi. So suppose it's n pi. So we can write this as sin P pi equals sine n pi. Now we can see that P equals n. Now what we will do is put back this condition in equation number 2. This equation. Putting P equals to n in equation 2. What do we get? Y equals C1 cos NCT plus C2 sin NCT into C4 sin NX. Now we will put the conditions for time. So at the beginning, at t equals 0, we know that y equals 0. Now we will put the conditions for time. So at t equals 0, y equals 0. Now this is my third equation. We will put this in the third equation. Putting t equals 0, y equals 0 in equation 3. What do we get? Y equals C1. The sign term in equation 3 becomes 0. So C1 plus 0, C4 sin of Nx. Now what can we say from this thing? And y equals 0, sorry. So y equals 0. So what can we say? We can see that C1 equals 0. C1 equals 0 from this equation. Now we put C1 equals 0 in equation number 3. Putting C1 equals 0 in 3 in in equation 3, what we get? Now this is equation 3. Now since C1 is 0, this first term C1 cos nct is also 0. So what we are left is y equals to C2 sin nct multiplied by C4 sin of nx. So we get y equals C2 sin nct C4 sin nx. So now this is my final equation. So the general equation can be written as y equals C2 C4 sin of nct sin nx. Now I can write C2 into C4 as another constant, so let it be bn. So let C2 C4 equals bn. Now I write this as y equals bn sin nct into sin of nx. Now for every particle, well, for each point n equals 1 to infinity, this equation becomes the summation from n equals 1 to infinity. Now this is equation 4. So if I differentiate y with respect to time, what we get? We get the velocity. So we will differentiate equation number 4 with respect to time. Differentiating equation 4 with respect to time. What do I get? Del y by del t equals sin nx. It's a sin nx is a constant since we are differentiating with respect to time. So this is a constant sin nx. I just need to differentiate sin nct. So sin nct becomes cos of nct into nc. Now in the question a condition is given in terms of velocity, that is del y del t equals at t equals 0, like initially it is 0.03 sin x minus 0.04 sin 3x. So we can use this condition for the equation that we got for the velocity. So putting del y del t equals 0.03 sin x minus 0.04 sine 3x and t equals 0. Now suppose this is 5, equation number 5. In equation number 5, what we get? 0.03 sine x minus 0.04 sine 3x equals the right hand side. What I did, I just simply substituted 0.03 sine x minus 0.04 sine 3x in place of the velocity, that is the left hand side, which is equals the right hand side, that is summation bn nc sine nx. Now since time is 0, the cost term is also is 1. So this is the equation that we get. Now what I need to do next, I will expand this. I will expand the right hand side of the equation. How can I write this equation? Now 0.03 sine x minus 0.04 sine 3x equals, now for the first term n equals 1 and bn is b1, so cb1 and sine nx is sine x because n is 1. Now for the second term n equals 2, so bn becomes b2 and n is 2, so I can write this as 2cb2 sine 2x. Now for the third term I can write this as n equals 3, so bn is b3 and n is so 3b3 c into sine 3x. I can ignore the higher order terms since the left hand side does not have any terms associated with sine 4x. So it is visible from here. We have till the third term. If we have till the third term, it's sufficient to find out the coefficient. We don't need the higher order terms. So what I'll do is compare the coefficient on the left and the right hand side. So comparing the coefficients on both the sides, what we get. So comparing the first term, 0.03 equals CB1. So from here B1 is equals 0.03 by C. Now on the left hand side we do not have any terms involving sine 2x. So what can we conclude from that? That is the second term on the right hand side equals 0, since there is no term on the left hand side involving sine 2x. So we can write this as 2CB2 equals 0, that is B2 equals 0. But there is a coefficient for the third term on both the sides. So what can we write from that? Minus of 0.04 equals to 3c into B3. So from here we can say that B3 equals minus 0.04 divided by 3c. So what can we do next? We just need to substitute these values in equation number 4. So which one was my equation number 4? This equation. We need to substitute this in this equation. So it becomes y equals 0.03 by c sin ct into sin x. Since n equals 1, it can be seen from equation number 4 that the first term corresponds to n equals 1, the second term corresponds to n equals 2. Like that, if we expand, we get the final solution, and we need to substitute the values for d that we just got now, So the second term b2 is 0 as we calculated just now, and the third term is, so b3 we can write this as minus of 0.04 divided by 3 comes out to be 0.01333. So this can be written as 0.01333 divided by c. Now writing the second term of the equation, sin, in place of n we substitute 3 ct sin 3x. Now we can further take common, like y equals 1 by c 0.03 sin ct into sin x minus 0.0133 sin 3 ct into sin 3x. So this is the final equation. Moving on to the fourth question. A tightly stretched string with fixed endpoints at x equals 0 and x equals L is initially in a position given by y equals y naught sin cube pi x divided by L. If it is released from this position, find the displacement y. So in this question, we are given an initial displacement. In the earlier question, we were given an initial velocity. So what can be done? Again, we start from the same thing. We write the equation of the equation for the string. So the equation for the vibrating string is now again we know the solution for this is this can be written as C1 cos px plus C2 sin px into C3 cos pct plus C4 sin pct. So what are my initial conditions? At x equals 0 and x equals L, the displacement y is 0. So given y0 comma t equals 0 and y L comma t equals 0. Also we know that at t equals 0 the velocity is 0. Since it is mentioned in the question, it is released from rest. So the initial velocity is 0. Del y del t equals 0 at t equals 0, and for time 0 the position is given by the equation that is given in the question, that is y naught sine cube pi x divided by L. So these are my initial conditions. Now, what is the expression for sine 3 theta? We know that sine 3 theta equals 3 sine theta minus 4 sine cube theta. So how can I write sine 3 theta? Sine cube theta. So sine cube theta can be written as 3 sine theta minus sine 3 theta divided by 4. Same thing can be done with this given expression. In place of sine cube theta, I will replace 3 sine pi x by L minus sine 3 pi x by L divided by 4. So I will write y x comma 0 as y naught by 4 into 3 sine pi x by L minus sine 3 pi x by L. So the general solution is this one. I'm writing this again. Y equals C1 cos px plus C2 sin px C3 cos pct plus C4 sin pct. Now what can be done? Putting x equals 0 and y equals 0. Now suppose this is my equation number 2. and this one is equation number 1. Now putting x equals 0 and y equals 0 into, what do we get? 0 equals, cos term becomes c1, only c1 is there, and sine terms become 0. So c3 cos p into ct plus c4 sine p ct. From here, what can I conclude? c1 equals 0. So c1 equals 0. Next, we put c1 equals 0 in equation 2. Putting c1 equals 0 in equation 2, we get y equals c1 is 0, so there's no term containing c1, so c2 sine px into c3 cos pct plus c4 sine pct. Now again we have another condition, that is the other end condition, that is x equals n and y equals 0. Let this be my third equation. Now putting x equals a and y equals 0 in equation 3, what do we get? Y equals 0, c2 sine pl, c3 cos pct plus c4 sine pct, right? So from this we can say that sine pl equals 0. Now what does that imply? This means sine pl equals to sine n pi, or pl equals n pi. So how can I write p as p equals n pi by l? Now n can take any values, 1, 2, 3, any value it can take. So now substituting the value of p in equation number 3, putting the value of p in equation 3, we get y equals, so in terms of p we have to substitute n pi by l. So this is my equation number 3. So this becomes c2 sine n pi by l into c3 cos n pi by l ct plus c4 sine n pi by l into ct. So how can I write this? C2 sine n pi x by L, C3 cos n pi Ct by L plus C4 sine n pi Ct by L. Now we also know the condition for velocity. Like at time t equals 0, the string is at rest. So we know the velocity is 0. So for calculating the velocity, what can we do? We just need to differentiate this equation. So suppose this is my fourth equation. We just have to differentiate it with respect to time and then substitute the given conditions into that equation. Now, differentiating equation 4 with respect to time. What we get equals to C2. This term is constant, treated as constant since there is no term like the first term. It's a term containing x, so there is no term for t. So this can be treated as constant. So C2 sine n pi x by L. Now the first term in the bracket contains has t in it. So we need to differentiate this term. So what can I write for it? Minus of cos is differentiated. So minus of n pi c by L C3 sine of n pi c L t. The second term in the bracket also has a term containing time. So what can I write? Plus C4 n pi c divided by L cos of n pi ct by L. So this is my term for velocity. Now what is the initial condition given? Velocity is 0 at time t equals 0. Now we just substitute it. Suppose this is my equation number 5. Putting velocity equals 0 at t equals 0 in 5, what we get? 0 equals C2 sine of n pi x by L minus of. So this first term won't be there since sine 0 is 0. So this term won't be there. We will only have the second term in the bracket, that is C4 n pi c L, and cos t equals 0, so cos becomes 1. So this is the term that we have. Now from here we can conclude that C4 equals 0. C4 equals 0. Now what we do? We put this back in equation number 4. That is this equation. So what does that become? Putting C4 equals 0 in equation 4, this becomes y C2 C3 y equals C2 C3 sine n pi x divided by L into cos of n pi Ct divided by L. Now what I can do is, like the previous sum, I can write the product of C2 C3 as some other constant, suppose Bn. Now suppose Bn equals C2 C3. How can I write this as? Y equals, this is y, not y2, y equals C2 C3. So y equals Bn sine n pi x by L cos of n pi c by L into t. So what can I write it? How can I write this as? Same like the previous sum, I can write it as y equals summation of n equals 1 to infinity Bn sine of n pi x by L cos of n pi c divided by L into t. Now this is the general solution. So this is my general solution. So for time and let's go back to the question. What is it given at time t equals to 0? The initial position, that is y equals y0 sine cube sine to the power 3 pi x by L is given. So at time t equals 0, we know the initial position of the string. And this is my general equation. So what can we do from this question, from this equation? Now we need to put t equals 0, putting t equals 0 and y equals y0 by 4 into 3 sine pi x by L minus sine 3 pi x by L. Now suppose this is my equation number 6. In equation 6, what we get? Now in place of y, I just put this value. I just put this value in place of y. So it becomes y0 by 4 3 sine pi x by L minus sine 3 pi x by L equals Bn sine of n pi x by L. Now since time equals 0, so cos term becomes 1. So I don't have any cos term on the right hand side. Like the previous term, what I will do is expand the right hand side. How can I do that? So y naught by 4 into 3 sine pi x by L minus sine 3 pi x by L becomes, so in place of, for the first term n equals 1, so b1 sine pi x by L. For the second term n equals 2 plus that is b2 sine 2 pi x divided by L. Similarly for third term n equals 3, so it is b3 sine 3 pi x divided by L. So I'll expand this right hand side of the equation. So this becomes b1 sine pi x by L plus b2 sine 2 pi x by L plus b3 sine 3 pi x by L. So I just need to ignore the higher order terms, since on the left hand side we have we only need the coefficient for sine 3 pi x by L. So I will just equate the terms on both sides. Equating the terms, the coefficient rather, equating the coefficients. Coefficients of sine on both the sides. What I get? So from the first term we see that the first term b1 equals 3 y naught by 4. b2 similarly, there is no term of b2 on the left hand side. So there is no term of b2 on the left hand side. So b2 equals 0. Now again what I see is the third term, that is coefficient for sine 3x, 3 pi x by L is there. So what is b3? b3 is simply minus y naught by 4, and all other terms, for all other terms of b are 0 because no other terms are there on the left hand side. Therefore the equation number 5 the equation 5 becomes, so what is my equation number 5? No, not equation number 5. Which one? The equation number uh, three. So the final equation becomes, not equation number 5, the equation becomes y equals, the equation number 6 becomes y equals y naught by 4. So 3 sine pi x by L cos c pi t by L. The second term for the equation is 0. So I have only the third term, sine 3 pi x by L into cos of 3c cos of 3 pi ct by L. So this is my final equation. So this is the final equation for the string. So what did we do today? So this is the governing equation of the governing differential equation of motion of the string that is given by this equation. So in this equation, Fxt is the external distributed transverse force and S is the tension in the string. Now this equation can be written like this by taking the first two terms. Now if we differentiate this term Sx into del y del x, if we differentiate this term in equation 1, we get the first two terms of this equation. Now if my fxt equals 0, that is the external, if the external force is 0 and the tension S in the string is uniform, that is it's not changing, and mx is rho, I can write the equation 1 in terms of this equation, that is c square del square y del x square equals del square y del t square, where c is the velocity of wave propagation, that is given by square root of s by rho. Now, so this I have used these equations to solve my problems. Now for the first question, what was asked? It was asked to find the velocity of wave propagation. Determine the velocity of wave propagation in a cable of mass rho equals 5 kg per meter when stretched by a tension T. Here in this question tension was mentioned to be T in place of S. It was equals to 4000 Newton. So I know my tension, I know the mass per unit length. So I can easily calculate the velocity of wave propagation. So this comes out to be 28.28 meter per second. It's pretty simple. For the second question, a steel wire of 2 mm diameter is fixed between two points located 2 meters apart. The tensile force in the wire is 250 Newton. We have to find the fundamental frequency of vibration and the velocity of wave propagation in the wire. So here we have to calculate a number of things. We know the diameter of wire, we know the density of the, we can assume the density of wire to be this thing, 7830. So what we need for the wave velocity of wave propagation, we need mass per unit length. But what we know is the density, mass density. So that is 7830 kg per meter cube. So to convert that into the mass per unit length, what we do is we multiply it with area of cross section of the wire. So we know the diameter of the wire. We can easily calculate the area. So that is pi d square by 4. So my area comes out to be, so this is my area. We can just simply substitute in the formula directly. So we know density, we know the area. So we get rho to be 24.5987 into 10 to the power minus 3 kg per meter. So we also know the tension in the wire. It is given in the question. So the velocity of wave propagation can be calculated by the formula that we used for the first question as well. That is C equals to square root of tension by rho. So tension is given as 250. We calculated rho. So we get C. We get the velocity as 100.81 meter per second. Now for the first part of the question. What is the first part of the question? The first part of the question, the thing that we calculated is the second part of the question, that is the velocity of wave propagation. Now the first part of the question is determine the fundamental frequency of vibration. Now we know that frequency of vibration is given by omega is NC pi divided by L. Now for fundamental frequency n equals 1, that is C pi divided by L. Now we know L is the length of the wire. So here L is the length of the wire. Length of the wire. Now we simply substitute it and we get omega to be 158.35 radians per second. Now for the third question, it is said that a tightly stretched string with fixed endpoints at x equals 0 and x equals pi. These are the two fixed ends of the string. Is initially at rest in its equilibrium position. So if it is set vibrating by giving to each point an initial velocity. Here we know the initial velocity for each point. So what we are asked to find the displacement at any point of the string at any time t. So again we write the equation for the vibrating string. So the general solution can be written as it can be seen from equation number 1. So there are number of conditions given. Like for x equals 0, the displacement is 0. So y is 0. Now substituting y equals 0 and x equals 0 in equation 1, what we get? We get the sign terms becomes the sign terms in the second bracket becomes 0. We are left with only C3 since cos 0 is 1. So we can conclude that C3 equals 0 from this condition. Now again for x equals pi, that is the other end of the string, y equals 0. Now what we do? Now for x equals pi, y equals 0, we again substitute it in the equation. So y equals 0 and C4 sin p pi. We substitute at so this from this sin p pi equals 0. So sin p pi equals 0 means sin p pi equals sine of some multiple of pi, that is n pi. So from this equation we can conclude that p equals n. Now we put p equals n in equation number 2. So which one is my equation number 2? This one. C1 cos pct plus C2 sin pct into C4 sin px. What we get? We get y equals C1 cos nct plus C2 sin nct into C4 of, in place of p we write sin nx. Now what we do? We put other conditions for time, like for time t equals 0, y equals 0. So we substitute y equals 0. Now the first bracket. In equation 3, the term in the first bracket, the sign term becomes 0 and cos is 1, cos 0 is 1. So C1 is only there and C4 sin nx. Now from this from this equation we get C1 equals 0. Now again we put C1 equals 0 in equation 3, sorry. So y equals C2 sin nct into C4 sin nx. So rearranging the equation, we write it like this: y equals C2 C4 sin nct into sin nx. Now I can write C2 into C4 equals some other constant. Now the general equation is this one. This is my general equation. This is my general equation. Now now we know the velocity from the question. The initial condition for velocity is given. So if we differentiate the equation for y, we get velocity. Now I just differentiate the expression for y which I got. So sin nx is a constant because it does not have any terms containing t. It does not have t in it. So I only differentiate sin nct, that is cos nct, and multiplied by nc. By differentiating we get this thing. Now we just put del y del t equals 0.03 sin x minus 0.04 sin 3x and t equals 0 in equation number 5. that is I just substitute this in the place of velocity. So this becomes my equation, and I put t equals 0. So this cos terms becomes 1. Only sin nx is left. Now what I do, I just expand the right hand side of the equation so that I can equate the coefficients on with the coefficients on the left hand side. Now for for n equals 1, bn becomes b1. For the second term, n is 2, bn becomes b2, and sin nx is sin 2x. In place of n, I just put 2. Similarly, for the third term, it is like 3b3 c into sin 3x. And I ignored the higher order terms since the left hand side of the equation do not contain any terms apart from these terms. So I compared the coefficients on the left and right hand side. So comparing the first term, what I get is b equals 0.03 by c. The second term is 0 since there is no term containing sin 2x. So my b2 becomes 0 from that. But there is a term containing sin 3x, so I equate those two. That is minus 0.04 equals 3c b3. So my b3 becomes minus 0.04 divided by 3c. Finally, what I do? I put all this coefficient and I get this equation as my final equation for displacement y. So this is the final answer. For the last question, what it was asked, here we are given displacement, here we are given the position. Here we are given the initial position, not the not the velocity as in the case as in the last question. Here we are given the initial position. So again I write the equation of the vibrating string, and this is the equation. This is the solution. Now there are a number of initial conditions given for this question. That is, at x equals 0 for any time t, y equals 0 for y at end L for any time t is also 0. Also the velocity is 0 at time 0, but we are given the initial position, so x is given at time 0, that is y naught sine cube pi x by L. Now what I did, I need to replace the sine cube in terms of sine 3x and sine x. So we know that sine 3 theta, this we can use this formula. So sine 3 theta is 3 sine theta minus 4 sine cube theta. From here I can replace sine cube theta as 3 sine theta minus sine 3 theta divided by 4. So I replaced sine cube theta by this 3 sine theta. In place of theta I write pi x by L. And sine 3 pi x by L, and y not by 4 I take common. So next what I do, I substitute the boundary the given conditions, that is x equals 0, at x equals 0 y equals to 0. In equation number 2 what we get, the sign terms in the first bracket becomes 0. So from this I can conclude that C1 equals 0. Now I am putting C1 equals 0 back into equation 2. So if I put C1 equals to 0, the cost term becomes 0. We are left with C2 sine px and the terms in the second bracket. Now again I have another condition, that is x equals L, y equals 0. Now I put this condition in equation number 3. Now in place of x I put L, so the first term becomes C2 sine PL and the terms in bracket becomes C3 cos PCT plus C4 sine PCT. Now from this equation I can say that sine PL equals 0. Now if sine PL equals 0, that what does that mean? It means that sine PL equals sine n pi. N can be any number, like any integer. N can be any number 1, 2, 3. So P equals n pi by L. N can be anything like 0, 1, 2, 3. Putting the value of P now in equation number 3. In equation number 3, so I substitute P as n pi by L. So this is my final equation. Now again I differentiate equation number 4 with respect to time to get the velocity, so that I can put the conditions given for velocity. So again we know the velocity is 0 at time t equals 0. Now I put t equals 0 and velocity equals 0 in equation number 5. So that gives me C4 equals 4. Now again I put C4 equals 0 in equation number 4, this equation. So what does that become? The second term in the bracket becomes 0. So I am left with only C2 C3 sine n pi x by L into cos n pi Ct by L. So now again I take C2 C3 as some other constant Bn. So my final equation becomes, the general solution for the problem becomes y equals Bn sin n pi x by L cos n pi Ct by L, and the n varies from 1 to infinity. Now from the question we know the initial position, and we know the initial position. So for time t equals 0 we know that this is the initial position. So now in place of y I put this and I put t equals 0, so the cos term becomes 1. I am left with only the sine terms. So again I expand the right hand side of the equation. So that becomes b1 sin pi x by L plus b2 sin 2 pi x by L plus b3 sin 3 pi x by L, and I ignore the higher order terms since the left hand side does not contain any term beyond third term. So I observe that the second term sin 2 pi x term is not there on the left hand side. So my b2, the coefficient b2 becomes 0, whereas the b1 I can compare with the left hand side, which is 3 y naught by 4, and b2 equals 0. and B3 equals minus y0 by 4. So I just substitute the coefficients in my equation number 6. So this is the final equation. So this is my equation for the displacement of the string. So let's stop here.